Hello Math 1316 students, let's begin lesson 9, Trigonometric Identities 1. I hope everybody succeeded in the midterm exam. Now let's begin the second half of the course, and that begins with trigonometric identities. Remember the trigonometric functions? Well, okay, we just took the midterm exam, so everybody must remember everything, right? So we begin with a circle of radius r centered at the origin. Consequently, we have this Pythagorean identity, x squared plus y squared equals r squared. And from here, we can consider these 6 ratios, which we define as the trigonometric functions. Sine y over r, cosine x over r, tangent y over x, and cosecant, secant, and cotangent are the reciprocals, so we get these reciprocal identities immediately. And then remember the signs, a smart trick class. Alright, from those definitions, let us prove some trig identities. First, the simplest, the reciprocal identities. These follow immediately from the definition, so basically there is nothing to do, as a matter of fact. Cosecant, let me expand the font. Cosecant is r over y, while sine is y over r, so they're reciprocal of each other. Secant is r over x, and cosine is x over r, therefore they're reciprocal, and the same argument applies for cotangent. Now, one over cosecant is sine, one over secant is cosine, one over tangent is cotangent. You can prove those as well using the same processes. But come on, this is a bit too obvious. Now, this one may look obvious, and then the proof is really obvious too, but the implication is significant. So I usually name this one. Tangent is sine over cosine, and it's the formula number 2 for trigonometry. Number 2 in terms of level of importance. Tangent is sine over cosine, and how do we prove that? Tangent, as you recall, is defined as y over r. Where is it? Yes. Y over x, excuse me. Tangent is y over x in this picture. Vertical over horizontal. And then here, dividing the numerator by r, and then also dividing the denominator by r, which is non-zero real number. Actually, r is always positive, by the way. We get y over r, which is sine, and x over r, that's cosine. So we get this directly from the definition, and the proof is easy. Starting from the left-hand side, apply the definition, some manipulation, and reaching to the other side. Stop the playback and try the same to prove this one. Remember the definition of cotangent function, cosine function, and sine function. In case you forgot, there you go, the definitions of trigonometric functions. Okay, did everybody get it? Cotangent is x over y, and then apply the same thing, x divided by r, and then y divided by r. Dividing same thing from both numerator and denominator, so no change took place. Cosine of theta over sine of theta. So that's a proof. And to me, that's the most desirable proof, but there are alternative methods. Yeah, this one we just discussed. Alternative method is using cotangents as 1 over tangent and applying the previous identity. But it's easier to start from the definition directly. Yeah, directly from the definition. Right there, directly from the definition. That's actually better. Next, we just completed the formula number 2. Now, formula number 1, the Pythagorean identities. These three put together, we call those three put together as a one entity and call those Pythagorean identities. And then 3 of them put together forms number 1. As a matter of fact, these 3 cannot be separated, so I have to consider them as 1. Of course, the most important is a standard formula. Cosine squared plus sine squared is equal to 1. Why is that? Well, basically, this is what you have to do. Work it out. Eventually, this is what you want. Alright, what is definition of cosine? X over r. The definition of sine, y over r. Therefore, this is x over r squared plus y over r squared. That's what I get. Next, break up the parentheses. It's getting me too long. Can I do it? Well, yeah, okay, I can do that. Oops, sorry about that. I can put together the numerator because we have the same denominator here. And then, remember, x squared plus y squared, the numerator, must be equal to r squared. Everything came from the circle, remember? Yeah, the circle. So the numerator is r squared. And the denominator is r squared. And then, okay, that's equal to 1, and that completed the proof. By the way, I was printing, so I can write everything in a single line, horizontally like this, starting from the left-hand side, seamlessly reaching the right-hand side by a sequence of equalities. But in handwriting, it's going to be a bit difficult because you may run out of space. Or even in print, if your process is long enough, then you can't do it this way. In that case, we restructure the problem like this. So take this one to the next line, align the equalities. This one to the next line, align the equalities. This one to the next line, and then finally this one to the next line like this. The final answer you can sometimes abbreviate as like this at the final line, but even that is not really desirable. It's a bit better to do it this way, aligning all the equalities, nothing separated, and this is important. All this part must be kept empty. So this equality here continues from the previous. This one continues from the previous. And then this one continues from the previous, and this one continues from the previous, and so on. So moving up, and then nothing here, so they're everything here in the right hand side. Eventually, all these are the same as this starting place, cosine squared plus sine squared. So keeping this part empty is important. This is kind of grammatical rule. So computationally you may do things right, but if you do not follow the grammatical rule, then your computation may be right, but your composition may end up counted a bit wrong. And that's related to following appropriate grammatical rule. And as for proving trigonometric identities, well, proofs require their own grammatical rules, not just solution process or even less work. So you have to practice this, and this course, trigonometry course, is actually the kind of course designed for that. And this kind of proof writing will become a little bit less emphasized in calculus, as a matter of fact, and then later in calculus 2 it'll come back, by the way. Okay, so can you do the same thing to the second and the third identities? 1 plus tangent squared of theta is, and then work it out, and eventually 1. What am I doing? Secant squared of theta. Can you work this one out? Stop the playback and try it. Did everybody get it done? The definition of tangent and secant. Let's copy and paste this thing here. Okay, let's keep this as a reminder. So 1 plus tangent squared. So 1 plus, what is tangent? Y over x. And then somehow we have to work it out. And then we have to get secant squared out over x squared. How do you do that? Y squared over x squared. And then what? Well, if you take the common denominator, x squared over x squared plus y squared over x squared, yeah, it'll work like this. I just replace 1 here, which I just highlighted in green, into x squared plus x squared. Hard to read. Let's use blue instead. Now, taking the common denominator, x squared plus y squared over x squared. And then what's the numerator? X squared plus y squared, that's r squared. And then that is r over x squared, isn't it? And what is r over x? That's secant. Well, too long, so let's rewrite like this. Align the equality. Align the equality. Align the equality. Ooh, I have to do it several more times. In handwriting, of course, this alignment will not be perfect. I can understand that. But still, it's better to be expressed like this, and it's important. This part here, down below, that part should be empty. And the last one is left as an exercise for you. We're going to come back and do more.